This is our home automation system project. This was done for our junior design project EE337 at the Minnesota State University at Mankato. The group members here include Brady Sabatino, Tim Haberman, and Brandon Pope. For our home automation system, we decided that we were going to have our PCB go through a hyperterminal on a computer laptop. It's going to be controlling 3 individual 60-watt light bulbs, which all have power given to them right now from an outlet, so they can all be turned on manually, and there's no need to do all 3 of them. They do all work, and we can do that just to prove it. They are also in parallel with a hot wire, a 120 volt wire that gets run through the PCB, which when the appropriate command is given will turn on each individual light bulb, and that's in parallel so that it can override the switch even when the switch is off. But the second thing that we have that's being controlled is also a 120 volt outlet, which as of right now the only thing we have controlling that or have on that is a green rope light that's got EE described on it. And the third and final thing that's going to be controlled on our home automation system is a canvas window blind that's kind of hooked up here, and it's controlled by a servo motor, which is going to be also run through the PCB, which Brady will take over and tell you how the PCB is working.
Alright, so here's our PCB, which is run here by an Atmel Atmega 168A microcontroller unit. And basically the whole way the PCB is controlling everything is through the serial communication, and when the correct command sent from the serial port through our max chip and then down to our microcontroller, the microcontroller turn on the corresponding pin that it's told, and then a 5 volt signal from there will be sent to one of these solid state relays, and they use a 5 volt signal to close their switch that they have in there, enabling the 120 volts to flow all the way through, turning on the outlet or the light switch. And you can see here is our hot wire that is coming up all the time, and then our other 4 outputs. And every time one of the pins turn on, we also have, in parallel with the 5 volt signal going to the relays, a resistor and an LED. So kind of an error checking thing when the first output should be on. If it's not outputting but the LED is on, we know there's some kind of a problem somewhere over by the relay or the terminal connection. And to get the serial communication to actually work correctly, we need this MAX 232 chip, which changes the lower voltage level of the Atmega chip to a higher voltage level that the computer can understand when it's sending all of its information. And it uses a pumping capacitor setup, which is by these 5 tantalum capacitors here, which help pump the voltage up. And right now we're actually using the power through the programmer right now, but this is also set up. We have a connection for a 9 volt battery, which has a 5 volt regulator with it, which we can also use to power it. And to control the servo motor, we got right here 2 different outputs for servos. You can actually control 2 window blinds with this, but we're just going to show it with one, which is using pulse width modulation. And depending on the width of the pulse that the microcontroller sends, it will determine whether or not which way it should be rotating, or if it should just stay still like it is right now. So we'll head over to the GUI, and right here you can see is hyperterminal, and we'll turn on the program, and this is our first menu that comes up, and from here it's going to ask if our window blind is open or closed, which helps the program throughout the whole time to know if it should be opening or closing, or if it can't open anymore. So we'll pick one since it's open already. And here is our main menu now of all the different options we have to work with it. And from here, Brandon will explain what's going on while Tim works the magic behind the computer.
Alright, so back here with me, and right off the bat here I think we're going to go with, and we're just going to have Tim turn on light 1. And as you can see, light 1 has turned on, and if I go down here to the switch, because they are in parallel, nothing is going to happen. And likewise, now we can have Tim turn on light 2 and also light 3. There we go. And now that all 3 lights are on, again, The light switches, in fact, do absolutely nothing. And now if we want him to turn them all off, we can also tell him to do that. And he can go in any order he wants. They don't have to be 1, 2, 3 or 3, 2, 1. That makes no difference at all. The next thing we can do, we can also have Tim control the outlet, which you should be able to see our lovely EE turn on, and then it'll turn off after about 3 seconds, which is what we had it programmed to do. If need be, if we wanted it to stay on, if you wanted it to control, a speaker system or a disco ball or a fogging machine, we could have it do that. And then the last thing that we have it controlling is our blind. And as Brady described earlier, as soon as you opened it up, you had to tell the program whether the blind was currently opened or closed, which as of right now, it's open. So if he told it to open, which if he's doing that right now, it's not going to do anything, which is exactly what we wanted it to do. Otherwise, it'd be flapping over the top. But if we want him to hit the down, as you can see, the blind will go down. And it should stop about here, which it does. And then from here, now we can also tell it to go up. And the servo motor doesn't work on, or this particular one doesn't work on the number of rotations. It's actually timed. So that's why it takes it slightly longer to raise the blind due to the torque. It's obviously much easier to slightly drop the thing than to pick it back up. We also put in kind of a debugging thing for somebody like a technician or somebody that could do if the blind, after being run up and down, if it is slightly off, we can manually control it with a 100 millisecond delay, which Tim can show that. And now if he lets it go, it'll stop midway, or if he wants to go back up, he can also go back up. And all those commands are shown on the hyperterminal. And that is our junior design project, EE337, with Professor Hudson, and it's done by Brady Sabatino, Tim Haberman, and Brennan Pope.